Good evening. Today's quote is, better keep yourself clean and bright. You are the window through which you must see the world. Today's word is ethereal, extremely delicate, light, not of this world. In Marathi, you can say Swargiya. The windows give the church an ethereal glow. In the last lecture, we discussed the concept of inverse function. Now, f is a function from a to b. Can you tell me the type of this function? This function is 1, 1 and onto. Actually, there are two types of functions, 1, 1, many 1. This is not many 1 because many are not associated with 1. 1 is associated with 1. And this is not only 1, 1, but it is onto also. What do you mean by ONTO, onto? Onto means this is the codomain. Set B is called as codomain. Codomain is nothing but set of all images, that is range of the function. Okay, so what is the speciality of this 1, 1 onto? That is injective and surjective function. In this case, function from B to A also exists. Why? Every element of set B is uniquely associated with an element of the set A. So this function is denoted by, say, G, and G is called as inverse of the function f. While writing this, we write f raised to minus 1, but do not read this as f raised to minus 1x. You have to read this as f inverse x. So x is nothing but f of g of x. Okay, so this is about inverse of a function. You will notice that for function f, domain is A, range, that is codomain, is B. But for f inverse, domain is B and range, that is codomain in this case, is A. So domain and range, they are interchanged. So when you are asked to examine whether the given function or rather the two functions are inverses of each other, what will you do? You will verify whether f of g of x is x and g of f of x is also x. This is the reason. See, A to B. From x we go to y, and from y we again come to x, right? So this is composite of f and g. This is composite of f and g. Or you may also say from y we go to x and again we come to y. So you may say f of g of y is y. But usually in case of function, we consider that independent variable by x and dependent variable by y. Now, exercise 6.2, fourth one, just listen to me, but do write the solution after the lecture. Verify that f and g are inverse functions of each other, where f of x is x minus 7 upon 4 and g of x is 4x plus 7. Actually, if you use common sense, then also you can say whether one is inverse of other or not. For example, from g, consider g, first multiplied by 4 and 7 is subtracted. Now in case of inverse, first 7 will be subtracted and you will have to divide by 4. See, you can say that subtraction is the process which is inverse to addition and division is the process which is inverse to multiplication. Is that clear? Now, how to write the solution in exam? Fx is given, gx is given. Find out f of g of x. Note that this is composite of not f and g. It is composite of g and f. So what is g of x? It is 4x plus 7. So it is 4 of, rather f of 4x plus 7. Now to get f of 4x plus 7, you should know fx. See the cursor? You have to use common sense. That is why most of the students find this difficult, because as they say, common sense is uncommon. See, whatever is written here, subtract 7 and divide by 4. What is written here? 4x plus 7. So subtract 7 from that and divide by 4. Yes, 4x upon 4, that is x. Can you tell me the name of this function? I already explained this. This is called as an identity function. Usually function is denoted by y equal to. So y equal to x is an identity function. Can you tell me what will be the graph of this function? Yes. I repeat the question. Y equal to x is called as an identity function. What will be the graph of this function? You can type your answer in chat box. If your mic is not working, if you're not comfortable answering. Anyway, second, g of f of x is g of x minus 7 upon 4. Now, what is g of x? It is 4x plus 7. Whatever is written here, first multiply by 4 and add 7 to that. So it is g of x minus 7 by 4. Multiply x minus 7 by 4 and then add 7 to it. Yes, you get x, as composite of g and f is the same as composite of f and g, and each is x. That is important. F and g are inverse functions of each other. Nobody has answered to this question. Yes, what will be the graph of this function? Identity function. Y equal to x. It will be straight line. Bisecting angles in first and third quadrants. See, this is the line y equal to x, 45 degrees. Okay. Yes. Now we'll be doing second sum. Right now. What is f of x? F of x is x cube plus 4. And what is g of x? It is cube root of x minus 4. If you use common sense, you can tell me that yes, one is the inverse of other. Why? See, first you have to cube the number, add 4 to it. Now in case of inverse, first you will have to subtract 4. And what is the process inverse to cubing? Cube root. Yes, so it seems that one is inverse of other, but even if you can observe this in exam, you have to actually prove that f of g of x is the same as g of f of x. Okay, so f of g of x, this is not at all difficult. What is g of x? It is given, so you have to just substitute that. So ultimately we have to find what? F of cube root of x minus 4. Now to get f of cube root x minus 4, you should know what is f of x. If you want, I will write that as f of x is x cube plus 4. You have to use common sense. Whatever is written here, you have to cube that number or that expression, that term, and add 4 to it. Therefore, what is f of cube root of x minus 4? It is nothing but, see, cube root means raised to 1 upon 3. Okay, raised to 3 plus 4. You have to use brackets. Now what is a raised to m raised to n? A raised to mn. I will write x minus 4 directly, plus 4. Yes, that is x. Okay, so we have proved that f of g of x is nothing but x. Now tell me, I'm sorry. Now tell me what is g of f of x. Please do not take screenshot. So it is g of, what is f of x? X cube plus 4. Now I will mention this as g of x is, what is g of x? Cube root of x minus 4. I will write this as x minus 4 raised to 1 upon 3. Cube means raised to 3. Cube root means raised to 1 upon 3. What is g of x cube plus 4? See, whatever is written here, subtract 4 from that and take its cube root. So what is written here? X cube plus 4. First subtract 4, then take cube root. So x cube raised to 1 by 3. A raised to m raised to n. is a raised to mn. See, presentation is important. After this, I have to say as f of g of x is same as g of f of x equal to x, f and g are inverse functions of each other. Are inverse functions of each other. Okay. Yes. Now C part. See, if you know the concept of value of a function at a point, you won't find it difficult. Now C part, what is fx? X plus 3 upon x minus 2. What is gx? 2x plus 3 upon x minus 1. What is composite of g and f? F of g of x. What is g of x? 2x plus 3 upon x minus 1. Now to get f of this, it is better if we mention fx first. Whatever is written here, add 3 to it to get numerator. Whatever is written here, subtract 2 from that to get denominator. So what is difficult? Addition of fractions, subtraction of fractions. So multiply throughout by x minus 1. So 2x plus 3 plus, open the bracket, 3x minus 3 upon 2x plus 3 minus 2x plus 2. So what remains is 5x upon 5, that is x. Now, what is g of f of x? It is g of x plus 3 upon x minus 2. That is 2 times x plus 3 upon x minus 2 plus 3 upon x plus 3 upon x minus 2 minus 1. Simplify. You get x only. After that, you have to mention, if you want full marks, as f of g of x is same as g of f of x equal to x. F and g are inverse functions of each other. Now, I'll ask one question, you have to answer that. Consider sine, cosine and tangent functions. You know their domain and range. Do these functions possess inverse with their original domain and range? See, the answer to the question that do trigonometric functions possess inverse with their original range, domain and range? The answer is no. Why? Because the trigonometric functions are onto their range, but they are not one, they are many one. For example, here domain contains angle, and what is the function? Y equal to sine x. So clearly range is -1 to 1. This trigonometric function is onto closed interval -1, 1. See what happens. So most of the students, they do not remember about the part which is already explained in the class regarding range, domain, concept of this open interval, closed interval. When I say that the sine function is onto this particular closed interval, you should know the meaning of this. But it is not 1, it is many associated with 1. So as it is, sine function does not possess inverse. So in 12th standard, we are going to discuss that at present domain is capital R. What do you mean by domain? Domain means set of all values which can be assigned to x. So we restrict the domain, which is at present R, to closed interval -π/2 to π/2. See, we will be discussing this in detail in 12th standard. This is not part of 11th standard syllabus. But with this restricted domain, the function which is already onto becomes 1 also, so that it possesses inverse. Is that clear? Okay. Now, who will read question number 5? Question 5. Check if the following functions have an inverse function. If yes, find the inverse function. See, what is the criterion for a function to possess inverse? It should be 1, 1 and onto. Now, f of x is 5x square. What is f of minus 2? Same as f of 2, because square of negative number is also positive. So clearly, function is many 1. So it is not a function. Again, you will notice that if we define function from set of real number to real numbers, then square of a real number cannot be negative. So it is neither 1, 1 nor onto. But if it is not 1, 1, why to think of that? Just say that f is not 1, 1, so f inverse does not exist. What about second part? Very good. See, what does f of x equal to 8 mean? Assign any real value to x. Answer is always 8. F of 0 is 8. F of 1 is 8. Stop there only. Because 0 is not 1, but f of 0 is same as f of 1. Is that clear? So can we draw a conclusion from this? The conclusion is constant function does not possess inverse. F of 0, 8. F of 1, 8. If you do not like 1, take f of 1 crore also. As f is not 1, 1. It does not possess inverse. Can you draw the graph of this function? Yes, function is usually taken as y equal to fx. So y equal to 8. Y equal to 8 is a line which is parallel to x-axis and above x-axis. You had done this part in 9th or 10th standard. So this is B part. Now C part. Okay, see, presentation is important. F of x is 6x minus 7 upon 3. Now who will tell me how to prove whether it is 1, 1 and onto? See, we have done one sum of this type. This seems to be 1, 1 and onto, so inverse can be obtained. Yes, anybody? Now C part, f of x is 6x minus 7 upon 3. We assume that function is not 1, 1. That is, we assume that it is many 1. More than 1 means many. So we assume that fa is fb. Now what is fa? 6a minus 7 by 3. We equate that with fb, 6b minus 7 upon 3. So that gives me a equal to b. This means f of a equal to f of b only when a is b. So our assumption that function is many 1 is wrong. It is 1, 1. Actually, it should be on 1, 1. Okay. Now we have to prove that it is onto. In fact, we have to verify rather, because we are not asked to prove, we are asked to check. So we should not say that we prove that. We should say we verify. Let y be fx, 6x minus 7 by 3. So 6x minus 7 is 3y. So what is x? 3y plus 7 upon 6. So for every y belonging to R, we have x belonging to R, such that fx is y. So f is onto. As function is 1, 1 and onto, f inverse exists. And you should know that if y equal to fx possesses inverse, then x is what? F inverse y. Replace this x by f inverse y. You get f inverse y equal to 3y plus 7 upon 6. But while writing final answer, we have to write in terms of x. So we say replace y by x to get f inverse x as 3x plus 7 upon 6. D part, fx root of 4x plus 5. See, by root we mean positive root. If you want negative, we'll have to define like that. Fx is minus root of. If you consider both, then one associated with many, that cannot be a function. So here by root we mean whose range is non-negative, that is semi-open interval 0 to infinity. So for negative y, we cannot find x such that fx equal to y. So clearly f is not on 2, so f inverse does not exist. Now E part, fx is what? 9x cube plus 8. Let me explain first. But please do write the solution after the lecture. Let fa be fb. So 9a cube plus 8 is 9b cube plus 8. That is a cube equal to b cube. So a is b. I hope you won't say equal to plus minus b. Cube of minus b is not b cube. It is minus b cube. So fa equal to fb implies a equal to b. So clearly function is 1, 1. Let y be fx be 9x cube plus 8. So that gives me x cube equal to what? Y minus 8 upon 9. So x is cube root of y minus 8 upon 9. So for every y belonging to R, we have x belonging to R such that fx equal to y. So f is on 2, right? So as function is 1, 1 and on 2, it possesses inverse. I already told you that y equal to fx, if it possesses inverse, then clearly x is not f of y, but x is f inverse y. So f inverse y is now cube root of y minus 8 upon 9. But we replace y by x to get f inverse x as cube root of x minus 8 upon 9. It's not difficult. Now, this is an important concept, piecewise defined function. A function defined by two or more equations on different parts of the given domain is called piecewise defined function. F of x is 2x plus 3 if x is less than 0. And it is f of x only, but it is 5 minus x when x is greater than or equal to 0. Now you may ask me, by how? See the word defined. It is defined. You cannot challenge this. For 2x plus 3, it is to be used if x is negative. If x is non-negative, you have to use 5 minus x. Now use common sense. If you are asked to find f of 0, will you go for 2x plus 3? No. Is 0 less than 0? No. 0 is equal to 0. How can 0 be less than 0? So you have to go for this. So to get f of 0, use this 5 minus 0 equal to 5. What is f of minus 1? Is minus 1 greater than or equal to 0? No. Minus 1 is less than 0. So what is f of minus 1? It is 2 into minus 1 plus 3. That is 1. Is that clear? So this is about piecewise defined function. So we stop here. In the next lecture, we will be solving that f part from some number 5. Then I will explain 3-4 different types of functions, including step function. That is very interesting and important function. Along with that, fractional part function, signum function, etc.